Hello, everybody. We're the eMission team, and we're here to welcome you to choose eMission to reduce your emissions. We assume you're already aware of the issue of climate change, so we're not going to talk about it any further. Instead, we're going to tell you about what we think are some of the challenges in actually reducing greenhouse gas emissions from transportation. First, on the personal front, we see that mostly what people get is a generic laundry list of solutions. Oh, you should inflate your tires, you should combine your errands, you should take public transportation, you should ride a bike. But there isn't really a lot of feedback on how much each of these will help. If I just inflate my tires, is that enough? Am I done? In order to move this from the personal level to the institutional level, a lot of cities in the greenhouse gas emission reduction plans are actually trying to tell large institutions like employers that they should reduce the number of people who drive alone to work. But we think that the challenge here is not as much personal and institutional as it is structural. For example, even if I'm really motivated and I really want to take public transportation, here's an actual trip that I took yesterday. It was a 10-mile trip from Mountain View to Santa Clara. It should take me about 15 minutes to drive, but it takes 1 hour on Caltrain, which is supposed to be a frequent public transit option. We think that the reason that there are these structural inequalities is because of measurement inequalities. For automobile traffic on freeways, there are 39,000 freeway sensors that are streaming data in real time. For data about walking, there is a yearly count on certain trails that's done by humans holding clipboards. Guess which one gets optimized? Another challenge with the freeway-based systems is it tells you what the automobile flows are, but it doesn't tell you where the flows go to or from. So the institutions that are asked to reduce the number of people who drive alone to work don't even know how many people are driving alone to work. So the way they try to figure this out is by doing surveys. The surveys are conducted once every 2 to 3 years and are really very crude snapshots. I mean, they ask you how often you drove to work and so on and so forth. Institutions are really motivated to have better monitoring programs to track this because they know that if you don't measure it, you can't improve it. So to recap, we want to have, at the structural level, continuous automated data collection of all modes at large scale, aggregated for modeling and analysis. At the personal level, user feedback on their own carbon footprint, components of their carbon footprint, and the changes that they can make. And at an institutional level, recommendations on incentives that they can do that actually work, and ongoing monitoring. And we don't just want to do these changes, we've actually done them. We have a working prototype that is used by about 36 people as of last night, both in Berkeley and outside Berkeley. We have a demo that will be coming up shortly, and our next step is a large-scale deployment, hopefully at UC Berkeley.
Quickly describe the workflow for an ordinary user. The user gets a notification when she has trips to categorize. When selecting the notification, she's shown a list of trips. When she selects a trip, she's shown the start and end times and the route to help jog her memory, and she uses this information to select the correct classification. Once all the classifications are done, the app displays her carbon footprint results. These include a calculation of her carbon footprint and comparison with several other metrics that we think are useful. These are the optimal footprint for this user, which is what she would get if she used non-motorized transit for short trips and public transit for long trips. The footprint that she would have if she drove everywhere. We included this to allow users to feel at least a little bit good about themselves. And 2 statewide goals to reduce emissions. SB 375 mandates a 15% reduction in per capita emissions by 2035, and an executive order signed by Governor Schwarzenegger mandates an 80% reduction in all carbon emissions, not just transportation, by 2050. More details are available at the link, and there are several other metrics that are displayed.
Also see the commute mode share. Where do people live around the trip generator? What's the mode share for a specific zip code? What's the average commute distance to work and from work? What's their arrival time? and departure time. Emission can also do what traditional surveys couldn't do. We could do longitudinal queries to see if there's any improvement of the carbon footprint from time to time. We could also see the popular bicycle commute routes and car commute routes, so that transportation department can decide which bicycle lane should be improved with their limited budget, and also which routes to apply congestion toll.
Our team consists of me. My name is Shankri. I'm a PhD graduate student in the EECS department. Mogan Yin, who is a PhD graduate student in the Transportation Engineering department, who provides the domain knowledge. And Shanti, who is an undergraduate who's really interested in applying the lessons she learns in the classroom to real-world applications. We now invite questions.
So give us a sense of where you are in terms of what's next. So you have the app right now. What's remaining? What you need to do to make it into where somebody can start using it from a more.
So we actually, in basically the semester, we got both the apps to work. So the Android app and the iPhone app both work. The Android app is actually in the Play Store. So if you have an Android phone, please consider downloading it and helping us collect data. The iPhone app is pending review in the App Store. I'm sure all of you know how that goes. We have a backend working that provides some analytics. In our mind, the real challenge here is improving those analytics. There's actually a lot of work happening in the sort of smart transportation space. I mean, I'm sure all of you have heard about Uber. Waze is sort of doing this for just car traffic on city streets and for sort of reporting where issues are. Moves, which is the app that we use for the actual data collection, actually recently got acquired by Facebook. But all of them are able to do analytics up to a certain limit, but they're not able to do this sort of broad vision. And that's sort of where we see the real value in this going forward. It's also a really hard challenge, which is why no one's doing it. And which is why, as PhD students, we feel like we're in a good position to actually do some of that work, especially since we're working in this interdisciplinary field.
So can you talk about what are your thoughts of how you're going to mine that large volume of data that's coming in, and what unique analytics you're going to provide?
So the first next step we want to do is, like I said, try for a large-scale deployment at UC Berkeley with the analytics that we already have. Because already we have the analytics that would largely replace their existing surveys. Right? I mean, UC Berkeley conducts a survey every 3 years, and we can replace that. And with that, we will get a lot more feedback on how comfortable people are with actually using this kind of with this kind of app, providing this kind of information. We know that Google, for example, collects a lot of this information automatically if you have an Android phone, but a lot of people don't know that they're collecting it. In our case, we're going to make it really upfront that we're collecting this because that's sort of our raison d'etre. And are people going to feel comfortable with that? We're going to find out when we do the large-scale deployment.
Let's use UC Berkeley as an example because we're here. How much, you're talking about these 3-year surveys, how much budget is dependent upon the data that's collected from these surveys?
So I don't know the data for UC Berkeley. I do know the data for, I do know some similar data for Mountain View. So as you know, there's a huge new development coming up in North Bayshore in Mountain View where Google is trying to expand. And the Mountain View City Council is really concerned about, the traffic impacts and so on and so forth. And their budget for the precise plan for the North Bayshore area is $1 million, roughly. Now, of course, not all of that $1 million is going to go to the data collection, but, it gives an idea of the importance that's being placed on urban planning.
So maybe you mentioned it earlier, but what are your plans for deployment and testing and implementation? I know that you said it's available now, but do you have partnerships established to test it?
So we just developed it this semester. So our next, now that we have a demo, so because this is so different from anything else that they're used to doing, people are used to doing email-based surveys. People are not used to having your phone prompt you every time to categorize a trip. And so we felt like it would be much easier to go with a working demo and to say, look, this works. You know, we can give you the data that you're already used to getting, and now can we partner with you? Rather than saying, well, can we partner with you because this is what we want to do? Because that seemed like it was a lot less impressive. So now that we have the demo, which, you know, got working as of last week, midnight, we plan to take it to UC Berkeley Transportation Department, and then in fall, when the students come back, try for a large-scale deployment with them. And I think that if we do a large-scale deployment with UC Berkeley and maybe a couple of other generators in the Bay Area, we'll have a better sense of, you know, how comfortable people are with this, and we can tweak it as we go along. I'm a big believer in sort of prototype-driven development, because especially when you're doing something so new, it's just easier to just get a prototype out there, get the feedback, and then iterate on the feedback, rather than have a giant plan for 10 years that you may or may not execute.
Thank you.